To wrap up this unit, and in fact this module, we're going to look at a number of visibility modifiers, some of which we've seen before and some new ones, or a new one, or maybe two new ones actually. And we'll also look at the final modifier as well. So part of this is review and part of this is new material. This will actually conclude the first two chapters of your text. We finished chapter 10 already, and this is the end now of chapter 11. So let's take a look at some visibility modifiers. The new one that's being introduced here is the protected modifier. It's different from the others in that it is related to inheritance. If we look at the order in which visibility is increasing versus decreasing, the least amount of visibility occurs when you've declared something to be private. There is another visibility between private and this new one that we're about to speak about, protected, called default. And the default visibility applies when you haven't stated a particular visibility. So in other words, putting private or protected or public at the front of a class is an option, or in front of a data member or method is an option. You don't need to put anything at all if you don't want to. And if you don't put anything specific, then that refers to what is known as the default case. In other words, there is no modifier or none. So that has slightly more visibility than private. And the next level of visibility is protected. And we'll discuss in a moment how that works compared to default and private. And finally, the most maximum amount of visibility that you can have is public. So in increasing order, we have private, default, protected, and public. So what is protected visibility? Well, this means that the data is not visible, the data member or the method as the case may be, it's not visible outside of classes that inherit from the place where it comes from. So in other words, if we have a parent class and we declare something in there to be protected, then that makes it visible to any child class, or any subclass in other words, but it will still remain private outside of that context. We have a nice chart coming up on the next slide that puts all these different levels of visibility together and discusses each in a format where you can compare and contrast each of them. So how you interpret visibility depends on whether you're talking about being within the same class where something exists, or being in the same package but not in the same class, or being in a subclass, in other words a child class, or being accessed from a completely different package. If you have public visibility, then you're going to be visible in all of those different contexts. If the visibility is protected, then it's accessible in the same class, because everything is always accessible in the same class no matter what visibility level we're using. But if it's protected, that it'll still be visible in the same package, and it'll also be visible in any class that inherits from the class in question. However, it will be invisible if it's accessed from a different package. The default visibility, which means you haven't specified public or protected or private, and therefore we know this to be default visibility. In other words, no visibility specified. Then you're going to still be accessible from within the class and from within the same package, but you won't be visible in subclasses. So in other words, if something extends a class, that something is not going to see things that you haven't specified a visibility for. And likewise, if you access from a different package, you won't see things that have default visibility. And finally, the highest level of protection is private. And if you have private visibility, you are only visible within the same class. Being in the same package isn't enough, being in an inherited class is not enough, and being in a different package is certainly not enough. So the next thing you want to do, I think, is have a good look through this diagram and get very familiar with it. We're not going to go through this slide in detail, but what you should do during your study time is compare it to the preceding slide. The preceding slide explains all of the different levels of visibility and how they apply in different contexts. And what this slide is intended to do is illustrate that for you. So what you want to do is reconcile the previous slide against this slide and go through and determine sort of where inheritance is taking place, where things are in or not in the same package, and what levels of visibility have been specified, including default, in other words, no specification, and go through and reconcile everything you see here with the previous slide, because this slide tells you what should happen in each case. For example, you see instances where it says can access this or cannot access that, can invoke this or can't invoke that. So that's what we mean by determining whether it's visible or not. If you can access it, it's visible. If you can't, it's not visible. If you can invoke it, it's visible. If you can't, then it's not visible. And if you go through this chart and look against the chart that's in the previous slide, you should be able to reconcile what you're seeing here. When we're using inheritance and we have subclasses derived from superclasses, it turns out that you can change the protection method in some cases, that you can take something that's protected and make it visible to the public. But you can't do the opposite. In other words, subclasses can only increase the visibility of a method or a data member. They can never reduce it. So we have an example at the bottom of this slide. If we have a particular method and it's defined to be public in the superclass, it's automatically going to be defined to be public in the subclass, and the subclass can't change that, because to change it, it would have to reduce the visibility, and it cannot do that. On the other hand, if there was a method that was defined as private, or protected rather, because if it was private, the child class couldn't see it either. But if it's protected, then it's not public, but the child class does see it, and the child class could turn around and increase the visibility by making it public. Sometimes you might write some code that you do not want someone to be able to extend or override. In other words, you don't want classes to be able to inherit from you. There's a way that you can prevent inheritance and overriding by using something called the final modifier. We'll see an example of that in the next slide in a moment. The math and the string builder classes and the string buffer as well are all final classes. You're not able to extend from them, so you can't make your own child classes that derive from any of these four classes, and the reason you can't is they have been declared to be final classes. The final modifier then works like this, and we're using an example of one of the classes that we talked about on the previous slide, pre-existing classes that are final that you cannot inherit from. So in the math class, it's been declared to be final because when the math class is defined, it has the keyword final at the beginning. So you see where it says final class math. That means that no other class can now extend math. There is a variable, which is a constant, in the math package, and it's the value pi, and that's a really good example of something that you wouldn't want anybody to override with a different value. It just wouldn't make sense to permit that. So to make sure it can't happen, we say final static double pi and give the value, and then no other class can modify that. So this final method can't be overridden by its subclasses.